This video will cover Java control flow's branching statements. There are three different types of statements for control flow in Java: decision-making, looping, and branching. Branching statements are used to change the normal flow of execution based on some condition. Java has three such branching statements: break, continue, and return, all of which could come in two forms: labeled or unlabeled. I'll go over each of them with examples. If you're only interested in a specific branching statement, feel free to use the timestamps in the description below to skip to the relevant bit. The first one we'll cover is break statements. Break statements are used to terminate the execution and bypass the remaining code in a loop, and then transfer control to the line immediately outside the loop. It's mostly used in loops to stop the execution and come out of the loop. Break statements have two forms: labeled and unlabeled. A labeled break statement will terminate the outer statement that's specified by the label. An unlabeled break statement terminates the innermost loop in which the break statement has been called in. We've already seen the break statement being used in switch statements, but it could also be used to terminate for, while, and do-while statements. Just as a reminder, here's a general structure of the switch statements. The switch statement is similar to the if statement. It's used for decision-making, where only one case is executed depending on the value of the variable being tested. The break statements here are unlabeled. If you recall, in general, each case is evaluated even after the first match is made, unless the break is used inside the case to exit the switch statement. The role of the break statement is to exit a block of code to continue on with the rest. We've already seen how the break statement works in switch statements from a previous video we've done on switch statements. So, here's another example of unlabeled break statements, but this time used in a for loop. Here, we've initialized the counter to count up until but excluding 10. But if we hit I equals to 5, then we break out of the innermost loop. I'm saying innermost because if we had a nested loop here, say we had a for inside of a for loop, we would only break out of the innermost loop. In our case, it's just the one for loop, so we break out of this for loop and continue on with the rest of the code, which in this case is just the final print statement. When we run this code, it does exactly what we expect. It prints out the value of I up until 5, but when it hits 5, it leaves the loop and just prints loop complete. Labeled break statements, however, are needed only in situations where we have nested loops and need to indicate which of the nested loop we want to break from. Consider the following code. Third is nested in second, and second is nested in first. When we run this code, this is what we get as an output. Now we'll go over the code to understand exactly what this labeled break statement is doing. First, we will execute the innermost block of code. Here, we print out the first print statement, and then when we get to the if statement, if t is true, which it is, then we break the second loop. What this break statement does is it breaks the outermost loop specified. So the code will break out from this nested block of code and continue from after the label. In this case, the label is second. So these two print statements will not be executed, and the next line to be executed is enclosed within the first code block. So this is how the labeled break statement functions in this code to give the highlighted output. Now, we'll move on to the next branching statement. The continue statement skips the current iteration of the for, while, or do while statement and continue to execute the code for the next iteration. So, in a way, it is similar to the break statement. The break statement comes out of the loop entirely, whereas the continue statement comes out of the loop only for the current iteration, but continues after that. So let's look at an example of the continue statement working. Say we have a for loop that iterates over the integer values starting from 0 up until 10. If the current iteration is an even integer, we will continue, meaning we'll skip that integer value. Otherwise, we'll print out the current iteration value is an odd number less than 10. When we run this code, we see that indeed all of the even iterations are ignored. So that's the break and continue statement completely done. We now just have the return statement to look at. The return statement is used to explicitly return from a method, meaning it causes a program's control to transfer back to the caller of the method. At any point in the method, the return statement can be used to cause the execution to branch back to the caller of the method. The compiler will bypass any other code after the return statement, so it must be used at the end of a method. Return statements can also return a value to the calling method if we label the return statement. Here is the first example of the return statement in use. Consider this simple code. We will print out the first print statement. However, once the return statement has been called, nothing following it will be executed, and this is exactly the output when we run this program. This was a fairly simple example with only one method. So let's look at another one, this time using two different methods. In the main method, for the values 25 through 30 on each iteration, we'll call the checkEven method within this main class. This checkEven method will take in the iteration value I as the num argument and check whether this value is even. If it is, we print out the number is even and return true. Otherwise, if the number is not even, we return the number is odd and return false. The reason we attach true or false labels to these return statements is because the method itself has to return a Boolean value. We can see this in the method declaration on line 12. And with that, we've covered all three branching statements. I hope you found this video helpful. Thank you for watching. Please like, share, and subscribe. Any bit of support is very much appreciated.